Welcome to our training on zero-code analytics. This initiative is led by the AFRO's Agri-Food Working Group, the African Federation of Operations Research. The Agri-Food Working Group promotes research in agri-food supply chains in Africa for improved data-driven decision-making and enhanced food security. The goal is to support academics and professionals of logistics and supply chain fields. I'm Ali, a researcher of operations research. In this lesson, we will cover a more complex qualitative prescriptive analytics tool. We will first provide a problem, model it, and solve it using the TOPSIS method. The problem at hand is the choice between different decisions. We will use the decision to choose a mobile as our case. The mobiles have decision criteria which make up the decision matrix that we can see here. The decision criteria for the decision-making problem are price, memory capacity, camera quality, and style ranking. This means we have both quantitative and qualitative variables, which is style ranking. We will introduce TOPSIS, technique for order preference by similarity to ideal solution. Selects based on discrepancy to the ideal. Simple additive weight was introduced in the previous lesson. As in the SAW method, we must have different alternatives with no known prior dominance and multiple criteria to base our decision on. After entering the decision matrix, we have to create the normalized decision matrix. We do this by taking each value in the decision matrix and dividing it by the square root of the sum of squares of each value of the criteria. So the price of mobile 1, we take 250 and divide it by the square root of B3 squared plus B4 squared, and so on till B7 squared, as we can see in the formula bar here. We enter the dollar sign after the B here to lock down the row number when copying the formula. Thus, we get the normalized decision matrix. Now, let's say that as decision maker, I have preference over the criteria we are making the decision based off. Simply add the weights, which must add up to 1, and multiply them by the normalized decision matrix value. This will give us a whole new scale called the weighted normalized decision matrix. We're not over yet with TOPSIS. Next, we need to calculate the positive ideal and negative ideal separation by using the formula here. Basically, we use the sum of square of the difference of each value from the best and worst ideal. As we can see here, we subtracted each value from the ideal value, then squared them, and then summed them, then calculated their square root. Now we have the positive ideal separation and the negative ideal separation. You're advised to pause and check the formulas between the positive and negative ideal separation. Finally, we calculate the closeness parameter, which will give us the final ranking. The closeness parameter is the negative ideal separation divided by the sum of the PIS and NIS. We can see that here mobile 4 ranked highest, where in the SAW method mobile 3 ranked highest. You now have two qualitative decision-making tools to help decide between alternatives, SAW in previous lesson, which is simplest, and TOPSIS, which is one of the complex tools. You should use both and present them to the decision maker to base their decision. Our job as analysts is to present the data in a way that provides new insights to help make the actionable decision by the decision maker. Thank you for choosing to learn with us. This is our final lesson and thus closing the full analytics journey. We hope that you now are empowered with tools throughout the analytics journey.